Okay, we are going to talk about atomic masses. So these are kind of relatively new ideas, but quarks are these little tiny things, small particles of matter that exist, and basically they make up protons, neutrons, and electrons, which make up atoms, which were thought to be the smallest things in matter, or the building blocks of all matter, and that still is the case. Even though we know of smaller things like protons, neutrons, and electrons, and then the quarks that make those up, okay, we still believe that atoms are the building blocks of all matter. A quark is just a small particle, like I said, that makes up protons and neutrons, and there are 6 different quarks that can make up protons and neutrons. That's really all you need to know about it. So an element's identity. So elements are organized in the periodic table of elements based on their properties or characteristics. In other words, how many protons do they have? How many neutrons do they have? How much is their atomic mass? How big are they? How strongly do they hold on to their electrons? Are they metals? Are they nonmetals? Are they gases? Just kind of a bunch of different things, and they're all characterized or categorized based on these characteristics. But using these properties of an element, we can place it on the periodic table. Because of that, we can get a really good idea of its structure, so what it would look like if we could actually see it. So this is a really fuzzy picture of the periodic table of elements. We'll look at a better one in a second. So identifying elements. By looking at the periodic table, we can learn a ton. For example, we can find out the number of protons in an element, the number of neutrons in an element, the number of electrons in an element, the mass of an element, how reactive the element is, how conductive it is, and lots more. So how? Well, there are some numbers on each square of on each element square that tell us a lot. So the atomic mass is composed mostly of protons and neutrons in the nucleus. This is also known as the mass number. This is basically how much an atom would weigh, or an average atom would weigh. An atomic number is the number of protons in the atom. The number of protons also identifies the element. So if you have 6 protons, you are for sure carbon. If you have 16 protons, you are for sure oxygen. If you have 1 proton, you are for sure hydrogen. If you have 2 protons, you are for sure helium. It tells you exactly what atom or what element you are looking at. If you need to find the number of neutrons in an atom, okay, you can find the number of neutrons by doing the mass number minus the atomic number. So basically, using both the atomic mass and the atomic number, we can figure out the number of neutrons, the number of protons in an atom. We can also guess the number of electrons if it is a neutral atom. If it is not a charged atom, we can figure out our number of electrons. So this is what a symbol might look like. This is the atomic number, so this would be the number of protons in the nucleus. We have the symbol. Remember, this is a 2-letter symbol. Notice how we have it capitalized here and lowercase here. We have the name of the element, and then we have a mass number. Now, the mass numbers oftentimes have decimals in them, and that's okay. You just round up or down. So the mass number for this is 74. So we know this is the number of protons, so the number of neutrons would be this number minus this number, which I believe would be 42, so there would be 42 neutrons and 32 protons. Now remember, protons are positively charged. So if it's a neutral atom, we have to have the same amount of negative charge. So if there are 32 protons, that must mean we have 32 electrons to balance it out. Isotopes. So this isn't something we're going to hit really hard, but there are these things called isotopes. And isotopes are atoms of the same element that have a different number of neutrons than normal. So remember that each atom is identified by the number of protons it has, but the number of neutrons can vary, and so that gives it a new atomic mass. So when that happens, we put the chemical symbol for the element, or the elemental symbol, and then how much the mass is. So there's B10, that would be the atomic mass for that would be 10, so there would be less neutrons here. B11, 11 is bigger than 10, so that means there would be more neutrons in this element. And both can exist in nature, okay? And they have a little bit of different properties because they have different neutrons and because they have different atomic masses. Okay, so the average atomic mass is just all the isotopes of the atom. So it's kind of like looking at how much of each type of carbon atom exists out there. If you don't understand that, that's not a big deal. Okay, so we're going to do some practice here. And I need to get a periodic table up really quick. Actually, I think I have one. Okay, so here's our periodic table. And notice we have lots of lovely different elements. We've got boron, we've got carbon, nitrogen, oxygen, all those things that you've been hearing a lot about. And now we can look at this and we can compare. So I'm actually going to get out of this screen and we're going to look at it. It's going to be a little smaller, but we're going to be able to bounce back and forth between our periodic table and this. So we can find boron. There's boron right there, and its symbol is B. So we would just fill in B here. The atomic number is this one that isn't a decimal up top, and they go in order. So you'll be able to tell really quickly. Like they go in numerical order. So 5, 6, 7, 8, 9, 10. Down here's 11, 12, 13, 14, 15, 16. So they go in order, so it shouldn't be too hard to figure out which one's which. So the atomic number is 5, and this also tells you how many protons there are. So there are 5 protons. Now to find the number of neutrons, we would take this number and we would subtract 5, and that would give us the number of neutrons. And the mass number is 10. Okay? The average atomic mass is 10.81. All right? So I hope that part made sense. Now carbon. Carbon is 6. The number of protons, therefore, is 6. The number of neutrons, because it is 12.01 AMU, is 6. Oxygen. So we're going to fill this one in together. So really quickly, what is the symbol of oxygen? It is a, there's oxygen, it's an O. Okay. What is its atomic number? That's this one without the decimal that goes in order, so that is 8. And remember, the atomic number equals the number of protons, so protons is also 8. Now we're going to look at this decimal down here because that's the average atomic mass, and that is 16.00. And so that means the mass number is 16. And so to find the number of neutrons, we take this and we subtract this. So mass number minus atomic number is going to give us 8 neutrons. So sodium, another example, and I believe this is on the other side here. Yep, here's sodium. Okay, so that means that it is a atomic number 11, which means there are 11 protons, and the average atomic mass is 22.99, which means that the mass number is 23. So I take 23 and I subtract 11 and I get 12 neutrons. Okay, now let's try copper. Here's copper down here. So the symbol is Cu. Remember, first one capitalized, second one not. The atomic number is 29. So that means the number of protons is also 29. So the mass number is 63.55. That means that the average number is going to be 63. 63 minus 29 is, watch out, 34. All right, so we are going to be working on that a decent amount in class when you get back. So thank you very much.